Hello everyone. This video will be teaching you about significant figures. What are significant figures, or sig figs? Significant figures are the digits in the number that show how precise the measurement is. The more significant figures, the more precise the measurement is. They include all the meaningful digits starting from the first non-zero digit. So, more significant figures, sig figs, means it's more precise. Alright, so what are non-zero integers? As I said from earlier, significant figures are all the meaningful digits starting from the first non-zero integer. So, what are they? Non-zero integers. So, non-zero integers are numbers that are not zero, right? They're always significant. They're always significant. And they are never placeholders. For example, the number 1.48 has 3 significant figures. Why? Because 1 is not a 0, 4 is not a 0, and 8 is not a 0. Therefore, they all count as 1 significant figures, and there are 3 non-zero integers, meaning there are 3 significant figures. Now your turn. How many significant figures does the number 63,432 have? Feel free to pause the video. Alright, hopefully you got 5 significant figures. Let's see why. 6 is a non-zero number. 3 is a non-zero integer. 4 is a non-zero integer. 3 again is non-zero, and 2 is non-zero. And there are 5 of them. Therefore, 5 significant figures. Alright. Now let's move on. Let's move on to the zeros. So there are 3 types of zeros. 3 types. There are leading zeros. Leading. There are captive or sandwich zeros. And then there are trailing zeros. Alright, so what are leading zeros? Leading. So, leading zeros are the zeros that come before any and all of the non-zero integers. So they come before non-zero integers. So they're on the left side. Left, right? So leading zeros are never significant. They are never significant. For example, the number 0.00032 has 2 significant figures, SF. Why? Because all the zeros on the left-hand side of the first non-zero integer, which is 3, are not significant. Meaning, this zero is not significant, neither is this, neither is this, and neither is this, leaving us with 2 significant figures. Now your turn. How many significant figures does the number 0.000 0, 8, 3, 2 half. Feel free to pause the video. Hopefully, you got 3 significant figures. Now let's see why. All the zeros on the left-hand side of the first non-zero integer, which is 8, are not significant, meaning this 0 is not significant, neither is this, and neither is this, leaving us with 3 non-zero integers, which means 3 significant figures. Alright, now let's look at captive zeros, which I like to call sandwich zeros. Captive or sandwich zeros. So, what are captive or sandwich zeros? They are between two non-zero digits, which is why I like to call them sandwich zeros, because it's like in between two breads. So, they're between two non-zero integers, right? And since they are in between two non-zero integers, which are both significant, they are always significant. Always significant. Right? So, for example, the number 8,007 has 4 significant figures. Why? Because 8 is a non-zero digit. 7 is a non-zero digit. And these two zeros are in between, meaning they are both significant. They are sandwiched inside the two non-zero digits, meaning they are both significant, which means each number in this number is significant, which leads us to 4 significant figures. Now your turn. Try 0.080029. How many significant figures does this number have? And remember leading zeros as well. Feel free to pause the video. Alright, hopefully you got 5 significant figures. Now why is that? As we can remember leading zeros, these two zeros are not significant because 8 is the first non-zero digit. 9 is the last one, and 2 also comes before these two zeros. These two zeros are in between the 8 and the 2, meaning they are also significant. And now we can count 1, 2, 3, 4, 5, leading us to 5 significant figures. Alright, so our last zero is trailing zeros. Trailing zeros. Now, as the name insists, they're trailing the non-zero digits, right? So, trailing zeros are at the end of a number. They're on the end of it, or the right side. Right side, right? And they are only significant if their number has a decimal place anywhere, right? So they are only significant if there is a decimal place anywhere. So, what does this mean? Well, let's see. The number 400 only has one significant figure, right? So trailing zeros are never significant if there is not a decimal place, right? So there's no decimal place here. So these two are not significant, meaning this only has one significant figure, right? But now let's take the same number and add a decimal place. Suddenly, this number has 3 significant figures because this decimal place turns these two zeros into significant figures. And we already know 4 as a non-zero integer is also significant, meaning the whole thing is 3 significant figures. So now your turn. How many significant figures does 4070 have with these 2 zeros? Feel free to pause the video and take your time. So hopefully you got 6 significant figures. Now this one was a little bit difficult because you had to incorporate sandwich zeros as well. So this 0 here is significant because these 2 are non-zero integers, right? And now all 3 of these are trailing. They're after the only non-zero integer, the last one, which is 7. But you have to take a look at the decimal place, which makes all of these significant, which means every single number in this number is significant, which is 1, 2, 3, 4, 5, and 6. 6 significant figures. Now let's do math with sig figs. Math with sig figs. So let's start off with multiplying and dividing. Multiplication and division. So when you multiply and divide, you take the number with the least amount of sig figs in the original problem, and that's how many sig figs your solution would have. So least amount of sig figs. For example, let's do 34.91 multiplied by 0.0053, right? So this does equal 0.185023, right? But that has a lot of sig figs. How many sig figs does this number have? Because we have to find out which one has the least amount of sig figs. 34.91 has 4 sig figs because all of these are non-zero, right? How many does this number have? Well, now we can look back at our leading zeros and see that all the zeros before the 5 are not significant, leaving us with 2. Meaning, we would only have 2 significant figures in this answer. So now we'd round to 2 significant figures. So this means that this 0.18503 will turn into 0.19 because it only has 2 sig figs, so we got to see if this rounds up. And if the number after the second sig fig is above 5, we would round up to 9, and if not, we'd stay the same. But since it is greater than 5, or 5, it's 0.19. So that is multiplication or division with sig figs. Now we'll do addition and subtraction. So now let's see what we do when we add or subtract. Addition and subtraction. So when you're adding or subtracting, your final answer has the least number of decimal places from the original problem. So it has the least number of decimal places from the original problem. For example, 12.72 plus 34.1 plus 0.463 is equal to 47.283. Now let's see how many decimal places each one of these has. 2, 1, 3. So this one would have 1 decimal place, which would turn it into 47.3 because it has 1. So we have to see if it rounds up or down. 8 is greater than 5, so this 2 turns into a 3. So 47.3 is our answer. And that's all there is for sig figs. Thank you.